So our next session is the last one before we have a break, and it'll explore human-AI convergence in this new era of innovation that we find ourselves in. We're delighted to be joined by Nacho Floristan. He's Director of Generative AI Solutions Architecture, EMEA and APAC at Google Cloud. Nacho leads the Black Belt team for EMEA and APAC within applied AI engineering. Based out of Dubai, he's passionate about helping customers along pragmatic use cases, mainly around LLMs, agents, distributed training, and Vertex AI search. Nacho, you're very welcome. Over to you.
Thank you. It's a pleasure to be with all of you, and I'm humbled to be coming after Dr. Ahmed and Professor Hall. Super inspiring session, and personally, I'm a big fan of Fanar and all the goodness they are bringing to the Arabic world and the LLMs. Today, I will be talking about harnessing the power of human-AI convergence. So basically, how humans and AI are complementing each other, right? Good. We believe AI should be helpful everyone across different domains, right? So we have seen huge improvements around how we humans understand the universe and the planets and all the macrophysics that happen out there and for many centuries have been hidden and unknown. I will touch base a little bit about how we as societies are augmented by AI, how we navigate our cities better, how we anticipate Mother Nature disasters in a better way. At the same time, of course, how we are collaborating better with different countries in different languages, how we at work are more productive, and why not having more fun. And then computational-wise, the master of ceremony before was commenting something that we as Google released yesterday. The chip Willow is a huge announcement that we did yesterday together with Alpha Qubit, which is, again, AI at its best, complementing another mind-blowing technology like quantum computing. So for those of you familiar, quantum computing is no-brainer going to be the next big thing in computing. So we have seen like the Moore's law and all these transistors, evolution, and so on. Well, everything will be blown out by quantum. But quantum is, unfortunately, a bit unreliable on the way things are computed. But AI to the rescue is coming to, first of all, detect the errors and then mitigate the errors in a very predictable way, right? So yesterday, this new chip is in line with our story of chip supremacy and how we really want to bring it to the public and bring it to you for research, for more simulations, for drug discovery, and so on. So when it comes to cellular, we will, again, deep dive into that later on. And yeah, actually, we can go ahead. The way AI has been living with us has been remarkable and, in my view, in a very organic way, right? If we look back at something like 20, 25 years ago, we started using things like spell checkers and autocomplete. And nowadays, I cannot live without it in my mobile or even when I'm typing in a proper keyboard. It helps me as a non-native speaker to write English in a good way. It helps me when I'm writing with one hand on the phone. And again, I take it for granted. It seems that it always was there. But when it doesn't work in my mobile, I'm kind of lost, right? 2006, we started using translation. We started with text translation, and that was incredible. I don't think of the last time I opened a dictionary, and like, for example, German to Spanish dictionary, that was probably 30 years ago. Like, luckily, nowadays, we got used to translate with whichever technology you want, but all that is AI. And it's not only text translation, it's also visual translation, right? I can use my Google Lens and translate things. Or if I go to Japan, I can do real-time speech translation. And then I will make myself understandable with the technology that is actually mind-blowing and removes lots of barriers. We have a set of what we call foundational blocks or frameworks that have been helping the different developers, researchers, and why not humans to build AI on top of that, right? So things like transformers, like NLP, like BERT, and TensorFlow and whatnot, right? Kubernetes as well was helping to scale. And all that led into things like Gemini and some other competitors out there in the LLM ecosystem. One of them that we are extremely proud is AlphaFold, right? If you have been following the news lately, something like a few weeks ago, 2 of my colleagues in Google got a Nobel Prize for chemistry. Sir Demis Hassabis, the CEO of Google DeepMind, and John Jumper got the Nobel Prize for exactly this, AlphaFold, right? So 6 years ago, they were exploring and researching how to understand proteins in a better way. You probably know proteins are the foundation of life, right? They are the building blocks that generate different molecules and basically life, right? So proteins by themselves are just a concatenation on chains of different amino acids. And these amino acids have a really interesting way of combining each other and then forming super complex structures in the 3 dimensions. And it was unknown. It was unknown how they and why they position themselves in different ways. So we have something like 200 million proteins, and most of them were unknown to the researchers. And AlphaFold, and now, by the way, it's AlphaFold 3, so there has been some iterations. And we have recently open sourced it for non-commercial use, for researchers, for universities, for anyone that wants to use AlphaFold to basically enhance and improve their research, right? So we truly think this is helping vaccines and drug discovery. So let's see a little bit more
how the proteins go from a string of amino acids to a compact shape that acts as a machine and drives life.
When you find out about proteins, it is very exciting.
You could think of them as little biological nanomachines.
They are essentially the fundamental building blocks that power everything living on this planet.
If we can reliably predict protein structures using AI, that can change the way we understand the natural world.
So is it really a big deal? Definitely. It's making a revolution of how our researchers are, for example, discovering the cure for cancer, right? So University of Naples are using AlphaFold and the protein database to understand a bit better how the different molecules and biological systems are interacting with each other and are fighting against the cancer. At the University of Oxford, researchers are using AlphaFold to improve the vaccine of malaria and make it more effective and more spot on. One of the favorite one that I have, and by the way, this is only an example out of 2 million researchers nowadays are using this in 190 different countries. So this is very popular in the academia and the, let's say, life science community, is how the University of Germany and Portsmouth are working to create new or discover new enzymes that will transform plastics and microplastics into something that is harmless for the ocean and the environment. So as you can see, 91% of the plastics we humans generate are never recycled and eventually go into the ocean and go into the nature, right? And as you can imagine, that has a huge implication in animals and the environment by itself. So by creating these natural enzymes, we will be able, and we should be able, to convert all those plastics into different particles that are, again, compatible with the life and the environment. So it's the small things that, again, change the needle, and it all starts with AI, and it all starts with a different approach. Again, researchers used to do this kind of exploration for many years. Whatever took them years, now it's helping them to make it in months, right? So that's why we have seen so many progress lately around chemistry, biology, and also battery, right? So it's all these foundational blocks that help to be more efficient around exploration and research. At the same time, we truly believe in helping doctors to be more efficient and have a second thought of opinion. So for example, thanks to the multimodality of some of our services like MedLM, we are helping doctors to maybe find rare diseases or, again, confirm their diagnosis, all in a very natural way, all thanks to video, audio, X-rays, and many of the tools they use nowadays when consulting and diagnosing in the hospitals. Moving a little bit into society, well, fires have been forever in the history of Earth, right? But the way we have tried to fight against fires has been quite different. Luckily, with satellites nowadays, we can detect fires early. And the usual approach was, okay, like tell the fireman to go there and then kind of expect different variations of the fire. But thanks to AI and machine learning, we can detect early the fires and then predict, based on the database of history of lots of, unfortunately, fires that we have been suffering the last 100 years, analyze how the fire will evolve, and then for the firemen and firewomen, how to tackle and why not firewall these different impacts, right? So again, a mix of satellite imagery with AI at its best to detect and mitigate early the different fires. In line with natural catastrophe, 250 million people in the world are affected by floods, and this has a huge impact, something like $10 billion. And unfortunately, that really affects the developing countries. So again, AI, augmenting the capabilities of humans, are helping to detect early these possible floods, and then together with the local authorities, like we saw in the previous example, help migrate people temporarily to a safer area, right? So as you can see there, it will help you to understand how the level of water will reach into measurable units and how the different emergency teams should be working on that. Another progress we have seen around AI and society has to do with the way we navigate cities and how productive we are in terms of mitigating traffic jams and, again, making the citizens happier, right? So unfortunately, we spend a lot of time in traffic jams, and historically, the way we orchestrated and improved circulation around the city was with active sensors, some passive sensors, and all sensory that was helping the local authorities to design the traffic lights and how the different authorities are basically synchronizing the different traffic lights. But we at Google are lucky to have Google Maps, so we have real-time information of how people navigate and how people are willing to take different routes. So again, an augmentation of human capabilities together with the real-time data and the crowdsourcing data that we have make it possible to have a Project Green Light. So we are working with 14 cities globally, including some of the most crowded cities in the world, like Rio de Janeiro, Seattle, India, and one city as well in the Middle East, to collaborate with the local authorities to basically reduce up to 30% of the stops that a car is doing through an itinerary, and then reduce 10% the emissions, because, of course, the more you have the cars driving around the city, the more pollution and the less happiness you have in the citizens, right? So that is truly remarkable. At the same time, talking about driving and society, it's almost shocking. And when I saw the first figure from the World Health Organization, I noticed that 1.5 million people in the world each year die out of traffic accidents, and this is incredible, right? So AI can definitely help to reduce that almost to the level of 0, right? So if you look at the statistics in the US, 94% of the crashes involve a human choice or a human error. And even worse, it's because human condition of being distracted while driving or being under the influence of drugs or alcohol or, again, pure human errors. So luckily, the technology of AI is here to drive following the rules. And if all have this technology, we truly think we can reduce to like a minority level of casualties. So as you can see, we covered some of the different domains where humans are augmented with AI. And we can't wait to see what you are building with the AI blocks. Thank you very much.